Hello, and welcome to this edition of the Secure Networks, the Endace Packet Forensic Files, with your host, Michael Morris. Our special guest this week is Steve Tsirtsonis, Director of Defense Sales for Endace. Steve, welcome. Thank you for joining. Tell us a little bit about yourself and your background.
So I've been working in the defense industry now defensive cyber for nearly 25 years now. So I'm old school. I've worked on both sides of it. So I've been client consultant, actually delivering and deploying these things. And I'm with Endace now for 10 years, nearly 10 years, which is a good old spell. And I now head up the government and defense side of the business for EMEA. That's really good.
Steve, your experience and your longevity in working in the defense space is one of the reasons we wanted to get your insights for our listeners. So I think it'd be good to start off with your view of the overall threat landscape that government customers are having to deal with in today's climate. And what are some of the big challenges that keep government security teams up at night?
Yeah, sure. The nice thing about government cyber is it's really interesting. If you're technically cyber biased, the government landscape for cyber I find much more interesting than the commercial side of the world, and there's a few reasons for that. Things go beyond just technical capabilities. It's all about nation state scale cyber terrorism. It's the most complicated network environments in the world. It goes from the technical to the physical. It goes huge amounts of resource and major global players all battling it out for information superiority. So you get everything from massive world leaders with entire divisions of cyber people and spies and so forth, all deliberately targeting assets of their foes. So it means that from a cyber standpoint, it's the insider threat, so spies, people being blackmailed. It's the extremely high value assets. So you get things like battleships and bases and forward operating locations, all being targets and at cyber risk. And having to work in that environment is a really interesting environment to work in, because you have to think so much further beyond just firewalls locking down and so forth, because you don't really know what you're going to expect. You do, there's precedent for what's going to come in, but the threat could come from anywhere. And when you're dealing with fixed locations, mobile assets, space, satellites, mobile communications, it's the threat is significant because it's always there and it's lives at stake, and the people that you're defending against have got so much resource and are so highly motivated to compromise your systems. So yeah, the threat landscape within government defense or critical national infrastructure it's real, and it's severe, and it's extremely variable.
No, I think that's tremendous insight. I think, like you said, it's a level of beyond what most enterprise corporations have to deal with because of the life and death nature of things.
They get it. If you look at who is out there and what's high profile at the moment, within the government space, it's power, gas, military intelligence, counterterrorism, and that sort of stuff. But within the commercial space, you've got things like intellectual property theft. If you're a pharmaceutical and you've invested billions in your latest drugs or whatnot, there's actual live things going on right now where nations are head to head because of commercial theft. So yes, it's different, but some of the threats are comparable.
Yeah, no, great point.
Yeah, if that makes sense.
How do you think it's evolved in the last 5 or 10 years, right? The security landscape is definitely changing. How do you view it differently?
The thing is, I find within the government space is things take a long time. Okay, nothing happens quickly. There's no dynamic response to things. There's no adoption of the latest whatever widget is, just because of quite simply the scale that everything operates at. When you've got hundreds of thousands of users across very long-standing capabilities and assets have been put in the ground, and those assets are due to last for 50 years. You don't get a big shift, if you like, from what was done before to what is done now. However, that being said, everything is going more electronic and is going online, and people are becoming more reliant on frontline data. So there is more cyber capability. There's more cyber risk out there, and more resource and money has been thrown at it. However, the methodologies are very comparable to the way they have been. It's just more resources getting thrown at it. We are seeing a push more to open source. I think historically people have been buying equipment and just deploying it and hoping it would go. There is an acceptance that more customization is going to happen, and there's certainly a desire to bring more of that experience in-house. We see a lot of that with Snort and Zeek and all those sorts of capabilities. So yeah, there's no dramatic shift between now and 5 and 10 years ago, but there is a pull towards getting more in-house capability, and there's certainly a push towards open source.
No, that's some interesting points there. What do you see governments doing to evolve or combat this changing landscape, right? If there's more, obviously the scale, you mentioned scale, you mentioned the push for more open source tools. What other things do you see governments doing to evolve and combat the threat level?
Automation is a really important part of what we're seeing as well. So because the deployments or the architecture of government departments is so vast, there's huge amounts of information that has to be absorbed for everything from logs on servers to switches to routers to firewalls and wherever else, machine and SCADA type things. Wherever there is IP capability, or wherever there is technical capability, there's risk. And in order to try and manage that risk, statistics are gathered from everywhere. And trying to make sense of that is extremely difficult. And there's a big push to try and automate that. And a lot of that is just done through the workflow. So what we get is analysts with many tickets coming in each day, and it's just about trying to get the relevant information to first-tier analysts to say, okay, this is a risk. Verify, is this a risk real? Is it not real? If it's real, pass it on to the next tier. If it's a malware issue, provide it to a malware expert. If it's a rogue insider, pass it to the whoever would deal with that in order to try and mitigate that risk. So yeah, there's a big focus on automation just in order to deal with the vast quantity of alerts that come in on a hourly basis.
No, that's a great point. I continually hear of alert fatigue. I hate that word, but too much volume of events and alerts to look through. So
yeah, but things like what's helping this is things like the machine learning capabilities in there and all the various statistical analysis of these things. And so we're seeing a large push for just trying to help analysts deal with the volume and make sense of what's going on out there.
Mm-hmm. So along those lines, besides just the volume, are there specific types of security challenge that government entities in particular are facing in the security space, whether it be classes of threats, whether it be targets of information, whether it be challenges with tools? Are there specific things that come to mind?
There's always going to be the 0-day type stuff, but I don't think there's any one particular threat, which is the problem. It's not just trying to protect financial services databases. It's trying to protect really old equipment that's in the ground. It's trying to protect mobile comms gear. It's trying to protect battleships. It's trying to protect aircraft. So there's no one particular thing. It's just vast. It's just vast. And also, one of the biggest things to be concerned about is the people. Are people compromised? Because if we go back and just have a look at what the resources that government foes have, let's take a battleship, for example.
Mm-hmm.
there will be specific divisions who are just targeted on looking at that battleship. They'll know what it is. They will know the components that are on there. They'll know where it's located in the world. They'll know when it's next coming in for its service. They'll know its crew. They'll know its captain. They'll know the senior officers. They'll know the schools where their children go to. They'll know the clubs that their wife goes to. So you can do extremely accurate spear phishing. For example, you could say, right, I need to access the captain's tools, whatever they may be. Therefore, I'm going to send an email from the school, because I can break into the school and I can convince the captain to click on something. So the real threat is just the motivation and the capabilities of the foes who are targeting that. And they've got all manner of tools in their arsenals. They've got entire spy agencies. They've got teams of developers. They've got, vast resources in order to try and target these tools. And that's probably the most significant threat.
Yeah, no, that's a great point of the amount of vast resources that you have to battle against. You mentioned earlier, many government agencies have had a history of much longer term planning and kind of this thought process of we need to build an in-house sort of mentality. As the security landscape is so dynamic, are you seeing that historical approach of everything in-house changing? And if so, how?
Yeah, so we are. So historically, we find governments like to buy something and know what they're getting. Okay, so they do extremely large procurement exercises, and within the procurement exercises, it's defined, I want this, it's going to be delivered like this, and it's going to look like this when it's finished. And if there's any deviation from that, well, I need some money, please, in order to pay for that. So it's expensive to deviate from that. So we're finding we're finding quite an appetite for more sprint methodologies, where the government agency or whoever it would be require a capability, they pay for it. More of a solution which is going to evolve, and they'll have preset. First 3 months we'll have this to this. This is what we'll deliver after this. Right, we like what you've done here. We'll pivot it, and it'll change to this, or we don't like that anymore. Take that away and change it. And we're finding that is proving to be quite successful, certainly in the cyberspace where things are far more dynamic.
That's interesting. Okay. So as government organizations are evaluating and implementing more off-the-shelf security solutions, or at least components, what are some characteristics of those tools? And are there areas like SOAR or AI or XDR where they're focusing more of their time, attention, and money?
All of the above. Because environments are so complicated. It's not just the amount of equipment out there. There's the fact that there are multiple prime contractors all doing different parts, and they all have to work together, even though they don't necessarily want to. And it makes for a complicated environment to operate in. And that means, and you get different primes will be providing the SOAR capability, different primes will be hosting, cyber tools and sensors and all that sort of stuff. So it's a real mix of everything, and necessarily so. Just through the complexity of what's out there, different types of tools are needed to do different sort of things. And I'm going to say machine learning and not AI. Machine learning is an extremely important part of just trying to make sense of the vast amounts of data.
Okay.
And focusing analysts on where they need to look. There's no point in having all this information if you don't know where the threat is.
Right.
And using the various tools and capabilities, a mix of open source, a mix of vendor technologies, essentially best of breed for this, best of breed for that, best of breed for that, all brought together into a large security architecture, if you like.
Right. Well, if all of this isn't enough that you've already highlighted, how has COVID impacted the government space and in security, of course, as a general rule? But a lot of tech companies are used to remote workforces to a greater extent than most government entities. So, how do you see it changing government?
Well, for one, it means that I have to sit at my desk all day, every day, and have done for ages. Hopefully, things are going to open up. It's a significant challenge for new capabilities. It's a significant challenge right the way across the board. Governments have had to make the change for remote working. And we've seen a significant increase in our business because of that, because they've just had to scale up to allow secure remote working up to certain classifications. And what we found, a positive impact of this in some of the countries has been there's always been a desire in certain countries to get more in-house capability, to be more self-sufficient, not to have to rely on pulling in contractors who specialize in this and this and this. And the fact it is harder for people to travel means that the overall ideal of having in-house capability and having local ability to do things is being accelerated, because the local teams are having to be more self-sufficient. And so one of the impacts is people are becoming more self-sufficient. It's not, that's the only positive I can come up with. Other than that, it's hard for everybody, and significant money has had to be thrown. We've seen it in multiple countries across the world, in remote connectivity. They still, people still have to go on site for the higher security tiers, but it's not fun, and it's proven to be a challenge. And it means that we can be less. It's harder for us to help a customer out if we're doing things remote as opposed to being on site.
Yeah, I've had a number of guests talk to me about the much heavier increased expectations and concern around the VPN concentrators, right? So getting that remote access in, making sure it's performant, and making sure it's secure, right? So clearly some new bottleneck points that maybe weren't as heavily stressed in the past.
Yeah, but if you look at the things which have developed, just within Endace, we've got far more capable remote communication capabilities. Everybody's firing up their webcams, and we have much better collaboration tools in place, because we're not seeing each other as often, and that's something which has been replicated everywhere.
Yeah, no, that's a great point. So, Steve, one of the questions I always like to ask our industry experts is, looking out, you're a forecaster. What's the one thing you look for or you recommend for people to think about and to maybe really pay attention to over the next 6 to 18 months in this constantly shifting battle for cybersecurity?
Yeah, there's going to be more automation. Certainly at the high levels of business. So there's going to be a requirement for, as the threat landscape increases, as people are doing more remote working, there's much more touch points across the network at risk, which then have to be monitored and made sense of, and risks mitigated. So there's going to be a lot more automation around that. What we're finding with the work that we do is we're finding there's a desire to be much more dynamic with your sensors. So be able to deploy capability and rapidly change that capability. So instead of putting physical boxes in the ground, be able to virtualize your security architecture. There's all sorts of benefits for that, but it means that you can chop and change much more easily and test much more easily, and that's something which is extremely hard to do at classified levels. So we are seeing more dynamism when we look at security analytics, security sensors, flow generation, metadata extraction, and all that sort of stuff.
Okay. Tremendous. Thank you, Steve, for taking the time and joining us, sharing your insights and your expertise in how to build better secure networks. We ask our listeners to tune in next time for another edition of the Endace Packet Forensic Files. For more information about Endace's network packet capture platform and our integrations with our Fusion technology partners, please go to endace.com. Steve, again, thanks for joining, and have a great day.
Thank you. You too.